question 1, we are estimating a proportion. That's the sample proportion minus the error is less than the true proportion, which is less than the sample proportion plus my error. The sample proportion in this problem is they've had 408 successes divided by 865 data in the sample. For 408 divided by 865. And if we approximate this answer to the nearest 10 thousandths, we get 0.4717. This is what we're going to use. We're going to have to compute our error. And in order to compute the error, we need to know what the confidence level is. This problem requires us to use the 95% confidence. So we need z-values associated with the 95% confidence, and we find they are 1.96 and minus 1.96. Our error formula is z alpha over 2 square root sample proportion 1 minus the sample proportion over the sample size, where 1.96 is our z alpha over 2 value. Entering this information in our calculator, we need 2 parentheses here, times 1 minus 0.4717, close that parentheses, divided by 865 in the sample. That's our n. Now if we close this, we will have computed the margin of error. Now, the margin of error to the nearest 10 thousandths is 0.0333. This is what we're going to use. So our sample proportion, subtract the error, sample proportion plus the error. Let's see what we get. So if we approximate these answers to the nearest thousandths, we get 0.438 and 0.505. Question 3. We are estimating a proportion, so we're going to use the proportion format. In this problem, there are 126 successes in the sample of 297. Approximating to the nearest 10 thousandths, we get this to be approximately 0.4242. In this example, we're using the 99% confidence level, which gives us z-values, or z alpha over 2 values of 2.575 minus 2.575. Our error formula is z alpha over 2 square root sample proportion 1 minus the sample proportion over the sample size, where z alpha over 2 is 2.575. Entering this in our calculator, we'll get 2.575 times square root. We're going to have to do a double parentheses again. We have to know what the sample proportion is. It is 0.4242 times parentheses 1 minus 0.4242. Close that parentheses. This is the complement, divided by the sample size, which is 297. Close our parentheses, and this will be our error. Approximating the error to the nearest 10 thousandths, we get 0.0738. So, if I take my sample proportion and subtract the error, sample proportion and add the error, I can answer the question. 0.4242 minus 0.0738, 0.4242 plus 0.0738. Now, if we approximate these answers to the nearest thousandths position, the 0 is in the thousandths position, digit to the right's a 4, so the answer is 0.350. 8 is in the thousandths position, so this answer is 0.498. Question 5. Question 5 is estimating a mean. So we will use the estimating a mean format. That's the sample mean minus an error is less than the true mean, which is less than the sample mean plus your error. Now here, they give you sample information, which is a sample size of 78, a sample mean of 409, a sample standard deviation of 37. So we already have the sample mean. We need the margin of error, which is z alpha over 2 s over the square root of n. In this question, they're asking for the 90% confidence, which means the z alpha over 2 is 1.645. This is the value we use for our z alpha over 2. So the error is going to be 1.645 times 37 divided by the square root of 78. Let's see what we get. We get an error of 6.892 if we approximate to the nearest thousands. So, sample mean is given. We just computed the error. If we subtract and we add, we can answer the question. (409) minus 6.892. 409 plus 6.892. Let's see what we get. It's 402.108. $415.892. So if we approximate this to the nearest tenths, we get 402.1 and 415.9. Question 7. We are estimating a mean. Sample mean minus an error is less than the true mean, which is less than the sample mean plus your error. They give us some sample information. Sample size is 43. Sample mean is 12.5. Sample standard deviation is 3.6. They gave you a sample mean, so we can use it here. Our error formula is z alpha over 2 s over the square root of n. So they're asking us in question 7 to use 95% confidence. Now, the z alpha over 2 value associated with 95% confidence is 1.96. This is what we're going to use here. So if I compute the error, 1.96 times 3.6 for standard deviation divided by the square root of 43 will compute our error. If we approximate this error to the nearest thousandths, we get 1.076. So we have our mean, we have our error, we can answer the question. 12.5 minus 1.076. 12.5 plus 1.076. If we approximate these answers to the nearest tenths, we get 11.4 and 13.6. Question 9. Question 9 is to estimate n, the sample size. Now, taking the error formula, z alpha over 2 times s over the square root of n, and solving for n, we get n equals z alpha over 2 over the error times the standard deviation raised to the second power. Now, in this problem, they want us to use the 95% confidence level, which gives us a z alpha over 2 value of 1.96. This goes here. So, using the information they gave in the problem, 1.96 divided by the margin of error of 124 times the standard deviation of 599 raised to the second power, we can compute the sample size needed. If we approximate this to the nearest whole number, or if we round up to the nearest whole number, 89.6 gives us 90. So we need a sample size that's approximately, or at least, 90. Question 11. Question 11, we have to estimate the sample size. Now, our error formula is z alpha over 2 square root sample proportion times the complement over the sample size. And again, if we solve for n, we'll get n equal the sample proportion minus its complement, z alpha over 2 over the error to the second power. They want us to use 90% confidence. 90% confidence gives us a z alpha over 2 value of 1.645. We're going to use that for z alpha over 2. So using all the information they gave in the problem, n will be 0.17 for its sample proportion times 0.83, which is its complement, and we will take 1.645 over an error of 0.07, raise it to the second power. .17 times 0.83 times 1.645 divided by 0.07 raised to the second power. Now if we round up to the next whole number, 77.9 becomes 78. Question 13. Question 13 is an estimate the mean problem, which means it's the sample mean minus the error, less than the true mean, less than the sample mean plus the error, and it's a small sample. They give us a sample size of 30, a sample mean of 77, sample standard deviation of 6.7, and they want us to use the 99% confidence. Now, the error formula here for a small sample is T alpha over 2 times S over square root of n. We need a T alpha over 2 value. We need a T value. We use these T values when we deal with small samples. Now remember, they want 99% confidence. So looking at our T table, 99% confidence implies 1% level of significance, or an alpha value. And we're going to look at the two-tail column. So using the T table, we also need a degree of freedom. Degree of freedom is n minus 1. Our degree of freedom will be 30 minus 1. 30 minus 1 is 29. Looking at our T table, we need row 29, column 0.01, 2 tails. Estimation is always 2 tails. What we find is 2.756. That means T alpha over 2 is 2.756. This is what we use in our error formula. .756. Standard deviation 6.7. Sample size 30. We have the sample mean. We'll use it here and here, and we have to compute the error. .756 times 6.7 divided by the square root of 30. We get an error of 3.371 approximated to the nearest thousands. So the error is 3.371. .77 plus 3.371, excuse me, let's make that minus, and then 77 plus 3.371. Let's see what we get. If we approximate these answers to the nearest tenths hundredths, we'll get 73.63 and 80.37. Question 15. We're estimating a mean, which is a sample mean minus an error, less than the true mean, less than the sample mean plus an error. This again is a small sample. So I have a sample size of 14, a sample mean of 664.14, sample standard deviation of 297.29. Now the error formula is T alpha over 2 S over square root of n. We need a t table to give us a t value. In this problem, they want us to use 98% confidence. Now this implies that we'll have a 2% level of significance, or that alpha is 2%. Degree of freedom will be 14 minus 1, n minus 1, which will be 13. So we are going to look for, on our t table, the 13th row, 0.02 alpha value, level of significance, and 2 tails. What we find is a T alpha over 2 value of 2.650 in the intersection. . This is what we're going to use. This is 2.650. We are given a standard deviation and we have the sample size. The margin of error formula gives us 2.650 times 297.29 divided by the square root of 14. We get an error of 210.55 approximated to the nearest hundredths. We're going to use this to subtract from the mean and add to the mean. The sample mean here is 664.15. 664.15 minus the error, 664.15 plus the error. 664.14, sorry. Six 64.14 minus 210.55. 664.14 plus 210.55. If we keep these answers, which are to the nearest hundredths, the answers will be 4, 53.59 less than mu less than 874.69. Mean is another estimation question. We are estimating the mean. It is a sample mean minus the error, less than the true mean, less than the sample mean plus your error. This problem, however, requires us to compute from a small sample. There are 8 data values in this sample. We're going to have to compute a mean using the mean formula. We're going to have to compute a standard deviation knowing it's the square root of variance. However, variance is going to be n sum x squared minus sum x in parentheses squared over n times n minus 1. This is by the shortcut formula. So I need a sum x squared value and a sum x value, 2 square. Now, considering my x values as 15, 15.5, 15, 15, 15.3, 15.3, 15.6, and 15. When I sum them, I get 121.7. This is the sum x. Column. Now x squared. 225 as 15 squared. 240.25, 15 and a half squared. 225, 225 for 15 squared. 15.3 squared gives us 234.09. Another 15.3 squared, 234.09. 15.6 squared is 243.36. 15 squared is 225. So that when I sum these values, I get 1851.79. The sample mean, sum x over n. Well, 121.7 divided by 8 is approximately 15.2125. This is our sample mean. Variance is n sum x squared minus sum x in parentheses squared over n times n minus 1. This will be 8 times the 1851.79 minus 121.7 to the second power over 8 times 7. I know 8 times 7 is 56, so I'm just going to put divided by 56. If I enter this all in my calculator, I find a variance of 0.06125. Now, I need the standard deviation. Standard deviation is square root of the variance. Or standard deviation is square root of 0.06125. I get a standard deviation approximated to the nearest 10 thousandths of 0.2475. So summarizing, I have a sample, size 8, sample mean 15.2125, sample standard deviation of 0.2623, 0.2475, and now we have to use the fact that they want us to estimate using the 98% confidence level, which implies alpha, our level of significance, is 2%, which is 0.02. Our degree of freedom, which is 1 less than the sample size, gives us 7. So using the t-table, we look for the 7th row, 2% two-tail column for our t-value, and we find we get 2.998. Let's double check. Seventh row, 2% two-tail, 2.998. That's correct. This is our T alpha over 2 value. So using the error formula now, T alpha over 2, S over the square root of n, this is 2.998 times standard deviation of 0.2475 divided by the square root of the sample size, which is 8. We get an error of 0.2623, approximated to the nearest 10 thousandths. This is our error. Using the sample mean minus the error, less than true mean, less than the sample mean plus my error. Sample mean again is 121.7 minus the margin of error of 0.2623. Sample mean plus the margin of error, 0.2623. We have a problem here. This is not our sample mean. Sorry. The sample mean was 121.7 divided by 8, which is 15.2125. Let's make sure we summarize that correctly. Yes, we did. It's 15.2125. Let's try this again. 15.2125 minus 0.2623. 15.2125 plus 0.2623. If we approximate these answers to the nearest hundredth, we get 14.95 and 15.47. Question 19 is to estimate the standard deviation. Well, using the format, let's put this over here. We're going to write down the estimation formula for the variance. And whatever answers we get, we will take the square root and we'll estimate standard deviation, meaning we're going to estimate standard deviation n minus 1 s squared over chi squared r less than sigma squared. This is a true variance. N minus 1 s squared over chi squared L. This is our estimation format. Sample information they give is n is 20, sample mean 10.2, sample standard deviation is 2.6. Now, we have the sample size, standard deviation. We need our chi-square r, chi-square L values. The chi-square values come from the level of significance. 99% level of significance. Sorry, confidence. Join our chi-square distribution. %, 0.5%, another 0.5%. Chi-square L, chi-square R. This is the chi-square distribution, which is strictly positive. So, if they have a sample size of 20, our degree of freedom is 1 less. It's 20 minus 1, which is 19. So we're going to have to use our chi-square table. Taking a close look at the chi-square table, we look for row 19. And we need actually two values. We'll need 0.995 and 0.05. The reason is if you use the chi-square table, you're always looking to area to the right of a curve, so that the area to the right of this chi-square value is 5%, which is 0.05. So, area to the right of that first chi-square value, which is chi-square r, is found by the 19th row, 0.05 column, and you find 30.144. This is your chi-square r value. Now, again, using our chi-square table, area to the right of the left chi-square value, well, 99% is 0.99, and 0.05% is what we were looking for, excuse me. So that the area to the right will be the 99 and the 0.005. So let's double check, see if we're okay here. Row 19 with 0.005 is 38.582. We made a mistake. 38.582. Because this is not 0.05, it is 0.005. That is 0.5%. So row 19, 0.005 column is 38.582. Now row 19, 0.995 row gives you 6.844. And this is a chi-square L value. So we got chi-square L, chi-square R. This also, to be clear, is a 0.005. 99% confidence level. So, going back to the format, we have a chi-square R value and a chi-square L value. We have N, we have S. So, let's write this down. N is 20, so that's 19. Using our format, we get 19 times 2.6 squared over our chi-square value, less than sigma squared, less than 19 times 2.6 squared over another chi-square value. Chi-square R is 38.582. Chi-square L is 6.844. Let's see what our calculator gives us. Now don't forget, we have to take the square root of this. we get approximated to the nearest tenths, 1.8. This is sigma. We took the square root of all three terms. $6.844. Don't forget, take the square root. Approximate this to the nearest tenths, we get 4.3. We have estimated the standard deviation. Question 21. Question 21 again is to estimate a standard deviation. So we know it's n minus 1 s squared over a chi-square r value, which would be less than sigma squared, less than n minus 1 s squared of a chi-square l value. Again, we have a small sample. In this problem, they give us 10 data values. So, if I list my data values, 13, 11, 10, 10, 12, 5, 7, 13, 6, and 11. If I add them, I get 98. I have to square each value. So 13 squared is 169. 11 squared is 121. 10 squared is 100. 100. 12 squared is 144. 5 squared is 25. 7 squared is 49. 13 squared is 169. 6 squared is 36. 11 squared is 121. When I add these values, I'll get 1034. So, computing the sample mean, which is the sum of the data divided by the sample size, we'll get 98 divided by 10 gives us a sample mean of 9.8. In order to estimate the variance or standard deviation, we really don't need that sample mean. But notice what we need is a sample variance. So the sample variance by the shortcut formula, n times sum x squared minus sum x in parentheses squared over n times n minus 1, what we get is 10 times 1034 minus 98 squared over 10 times 9. If I enter this in my calculator, I'm not going to divide by 10 times 9 because I know it's 90. I'm actually going to divide by 90. Hit enter, and I get the sample variance. Let's approximate this to the nearest tens, hundreds, thousands. 8.178. This is S squared is approximately 8.178. This is what I need. So using the format of n minus 1 s squared over chi-square value less than sigma less than n minus 1 s squared over a chi-square value. This will be a chi-square r value. This is a chi-square l value. N is 10. So 10 minus 1 will be 9. 9 times s squared. Well, sample variance is 8.178 divided by my chi-square r value. 9 times 8.178 divided by a chi-square l value. So what we're going to do is focus on the chi-square values. You have left skewed distribution. This problem, 95% confidence. Implies that alpha is 5%, or your level of significance is 5%. And in this right tail, you'll have half of 5%, which will give us 2.5%. In the left tail, 2.5% in the right tail. Right tail, left tail. Total is 5%. You have a chi-square L value, a chi-square R value. Since the sample size is 10, 1 less will give us the degree of freedom, which is 9. We're going to use the chi-square table. Looking for row 9, column 0.975, 0.025. 2 columns. Let's go back. Using the chi-square table requires us to know area to the right of a chi-square value. To the right of this value is 0.025. So, 9th row, 0.025 column, if we use our table, we find 19.023. This is going to be our chi-square r value. Going back, 95 is 0.95, so that the area to the right of the left chi-square value is 95 plus 0.025, which gives us 0.0975, or 97.5%. Row 9, column 0.0 or 0.975 gives us a 2.7 chi-square value. (2.7, 19.023). Chi-square L. Using our calculator. 9 times 8.178 divided by 19.023. Remember, take the square root of this. And we'll get 1.967. 9 times 8.178 divided by 2.7. Don't forget, take the square root. We get 5.22. So if we approximate to the nearest tenths position, 1.9 with a 6 to the right makes this add 1 to the 9, which gives us a 2. Approximate to the nearest tenths, you get 5.2. 2 less than sigma less than 5.2. Remember, taking square roots.